We've looked at how the periodic table was made. Now let's look at trends in elements in the periodic table. Be able to define, and we're going to do this with each one of these, the atomic radius, an ion, a cation, an anion, ionization energy, and electronegativity. Compare the structure of substances on a bulk scale to infer the strength of interatomic electrical interactions. We're going to be starting with defining those in this lecture and moving on in other lectures. Draw simple molecules based on electron interactions. Again, we're looking at electron interactions here, and later you'll be drawing molecules. Relate atomic radius, ionization energy, and electronegativity to periodic trends. Compare electronegativity between groups and relate ionization to chemical reactions. So you already know some trends. You know how the number of protons is going to go up as you go down in a period. You know the number of neutrons is probably also going to go up, just the atomic masses go up in general, and that the number of electrons is roughly equal to the number of protons unless you're dealing with ions. You know how electron energy levels work in the periodic table and what it means to have a filled electron shell. If you don't, go back because those were in some previous videos. So let's start with atomic radius. This is going to be if you had two atoms and they're right next to each other, the atomic radius is half the distance between their nuclei. I mean, you can think of it too as if an atom was roughly a sphere, the radius is, well, the radius. And of course, we also know with atomic radius that same charges are going to repel one another, so we're going to get a larger radius. Some elements are actually naturally going to form two atom molecules like chlorine, oxygen, and hydrogen, so it's easy to measure that. Some trends in atomic radius, what you're going to notice is that the radius decreases from left to right. And this is because you're looking at a single electron energy level, and the nucleus is going to be attracting electrons in that energy level more as you add more protons into that atomic nucleus. Remember that a period is generally going to have the same electron energy level. So as we're going down, we're also going to be increasing the number of energy levels. So that means atomic radius increases as you go down the periodic table and decreases as you go from left to right. Now, what is an ion? An ion is going to be an atom that has a number of electrons not equal to the number of protons. This means it has a charge. If there is a loss of an electron, this makes a cation, a positive ion. If there is a gain of an electron or electrons, this is going to make an anion. And we're going to see that this interacts with reactivity through the octet rule. Now, if you think of your representative elements and your s and p orbitals, what we want to get is in that outermost energy level, we want to get 8. Hence octet. We want to get 8 electrons in the outermost energy level, which is the s plus the p, which has room for 8 electrons. So generally, things that are trying to fill out their p orbital are going to try to gain an electron, and that's going to be forming an anion. And some other elements, such as sodium, are going to try to lose an electron, and when they lose an electron, they actually have a filled outermost energy level because they've lost the energy level above by losing 1 electron in their s orbital. This is also why calcium loses 2 electrons to lose those 2 in the s orbital, and that gives it a filled orbital below that. And this has to do with ionization energy. So again, you look at how larger atoms are going to have their electrons farther away from the nucleus, and they are going to have a lower ionization energy. Ionization energy is the energy that is required to remove an electron from an atom. For something like cesium, you can see that Cs down there, period 6 in alkali metals, you can see how that has a very low ionization energy. Whereas for something like fluorine, you have a very high ionization energy. It is clutching its electrons like Gollum clutching the One Ring. It's going to be very hard to remove those. Now, opposite ionization energy is electronegativity. How much they want to take on more electrons. So fluorine now is the most electronegative element. It really wants an extra electron, and it's not going to give up the electrons it does have. Cesium is the least negative element because it wants to give away its electrons. Now, what happens if you were to make cesium and fluorine react? I've got this little video. It's kind of fun. Now, ionic size, this one we're not really covering on the exam, but I just want you to think this one over because you can look at the ionic radius here, and what you see is that it decreases as you go from left to right across the periodic table, with fluorine being the smallest. But then you can see 2 lines here. Two lines. Why are there two arrows? Well, the first arrow represents cations. The second arrow represents anions. So that's going to be the loss of electrons and the gain of electrons. And you can see that this repeats the atomic radius trend